Parabolas have many real-world applications that are often overlooked or undermined. We rarely consider how these ideas and concepts are incorporated in real life, something we should always be mindful of. In this case, parabolas are valuable for the societal and technological advancements it has given us. Its various utilizations include scientific analysis and computation, technological incorporation, engineering and architectural applications, and data analysis, to name a few. In the following slides, we are going to understand the ideas listed above and see how parabolas serve as its backbone. Parabolas play an important role in kinematics, which is the study of objects in motion and is a fundamental of early physics. The concept to be discussed is projectile motion, which applies the quadratic equation and is modeled as a parabola when graphed. It expresses vertical height as a function of time. The base equation for projectile motion is y final equals y initial plus VOT plus 1/2 AT squared. In this equation, YO is the initial vertical height vector, VO is the initial velocity in the vertical direction, AY is the acceleration in the vertical direction, which is often gravity, or negative 9.8 meters per second squared. In this equation, the coefficients are arranged in ascending order and can be modeled and calculated algebraically as fx equals c plus bx plus ax squared. The equation is the foundation for calculating projectile motion scenarios that must then take into account factors such as air resistance, wind velocities, and other engineering/environmental factors. Its applications are incorporated in sports, defense, and overall trajectory predictions. The quadratic equation can and is applied in several fields of science that then serves practical uses in real-world scenarios and problems. Before the mathematical derivation of the quadratic formula, the earliest applications of parabolas was through architecture. Arches made for unique and lavish entrances and were a statement of wealth and grandeur. The gateway arch is an example of modern architecture, incorporating the beauty of the parabola. Many mathematical and geometric figures derive from inner creativity and are a reflection of human existence. Math is just as significant as any art in human expression and achievement. Parabolas are used in suspension bridges as a form of creating stable and safe structures using mathematical ingenuity. Suspension bridges use long cables that are connected between elevated towers. Its main cables support the suspension cable that holds the bridge deck. The parabolic curve seen acting on the main cable is formed between the tension and gravitational forces acting on it. The parabolic shape ensures equal distribution of compression forces. With reliable engineering applications, suspension bridges can safely span long distances. The mathematical concepts of parabolas are also incorporated in technology and can be seen in a range of applications. To understand the following two technological applications, the components and relation of the focus and directrix in a parabola must be understood. The directrix is an established line below or above the parabola that is equidistant between any point on the parabola and that point to the focus, a point which lies on the parabola's axis of symmetry. Headlight mirrors incorporate the functions of the focus and directrix in a parabola. Light emerges from the light source, in this case a light bulb, which is mathematically positioned and can be thought of as the focus in this example. Light is directed in all directions as any light bulb would do, but in order to concentrate and disperse that light source in a designated direction, the parabola serves as a reflector, and it focuses all that light in that one direction. The position of the light bulb acts as a focus, and the parabolic curve reflecting light within one concentrated area creates beams of light seen in car headlights and other vehicles. Similarly to headlights, satellite dishes also apply the following mathematical concepts and relationships. In this case, satellite dishes act as both transmitter and receivers. This means they transmit and receive signals. The feed horn, which is placed as the focus on a satellite dish, makes a transmission that is then reflected through the curved dish shaped as a concentrated beam. The signal transmits data via a satellite, which is then transmitted back to the dish to be received. The parabolic curve directs the signal and concentrates the data to the feed horn or receiver. The feed horn as any function like the quadratic equation considered. Its information can be reflected as data within a table, or as a graph displaying content. Like the many real-world applications discussed before, its information can be modeled as useful information and data. For example, knowing the curve of a headlight reflector in comparison to different models would help to understand the concentration of the beam or functions it is looking to serve. If you want to adjust the span of the beam or its strength, one must consider ideal factors through analyzing data. The same goes for projectile motion applications when comparing sports stats or seeing the difference performance of missiles. Data and graphical information is essential to many real-world scenarios, and in this case, its benefits are unprecedented. The examples discussed before us was to see how the mathematical concept of quadratics and parabolas is reflected in the real world. It is important that we are mindful between the relation of math and this world, and understand how humanity has long depended on it.